So we have seen ANOVA, analysis of variance, as of now, and we have seen the one-way ANOVA. What we discussed was one-way ANOVA test. So we have other types of ANOVA testings are there. The others are like, one second, let me just go to my website, and I don't know if I have the copy with me. If it is there, it is good. Yeah, we have two-way ANOVA. So two-way ANOVA test and with and without replication. So here in this case I'll be using an Excel. So our good old Excel sheet is very much helpful, especially when you work with tests like two-way ANOVA with and without replication. I just open this Excel sheet. Let me see if I can. Yes, this is the two-way ANOVA without one second. This is two-way ANOVA without replication. This is with replication. Just give me a second. Let me quickly open up. We will start understand the two-way ANOVA. As of yesterday, we discussed about one-way ANOVA. So I have used the case study wherein we saw that how to conduct the ANOVA test manually. So with formula, how we can do it. So usually we don't have to use the formulas manually. We can use the statistical package. With that we can do it. It helps our life very simple. If you use the statistical software, that is more than sufficient. Anyhow, I will show you little later how to conduct the test using the statistical software, especially in Python. And okay, now we will jump into understanding the two-way ANOVA without replication. Okay, so what is two-way ANOVA replication? So in the yesterday's session we looked at one-way ANOVA. So one-way. So what is one-way ANOVA? It is also called as one-factor ANOVA test. One factor. We have used only one factor there. So what is the only one factor? Can someone tell me what was the dependent variable and independent variable? As part of the case study, we have seen it yesterday. How many of you can tell me this one? The question is, I will repeat the question. In the yesterday's case study, one-way ANOVA, we have conducted the test manually. How many of you remember the dependent variable and independent variable? And independent variable. What was the independent variable and what was the dependent variable? So what was the objective of the test? Yesterday we conducted the ANOVA test. What was the objective of the test? Type it in the chat. Even if it is a mistake, let it be there. Mukilan or Mala. Mala is there. Mala is not joined. Oh, Mala joined. Okay. So how about college students? You can tell, right? What was the objective of yesterday? So the yesterday's test was cookie shop scenario. What do you mean by cookie shop scenario? It is not cookie shop, retail shop, right? We discussed about the retail chain case study. The objective of that case study, ANOVA case study, was so does keeping the items in the different part of the shelves have any influence on the sales? For that we conducted the ANOVA test. So what was the dependent variable? What was the independent variable? See, we have discussed about shelf, right? Shelf position. Sales is a continuous variable. I gave you the clue also. In the hypothesis testing, you gave me the thing, right? You gave very good, Karthik. Yeah, sales is a dependent variable, and okay, sales is dependent variable on position, sell position, right? Yes, Mukilan. So the independent variable is, so okay, the dependent variable is sales, and independent variable was shelf position. Okay, here only one independent variable, one factor. It is also called as a factor, right? Single factor. We have used only one factor called shelf position. But don't tell me we discussed about top shell, middle shell, and bottom shell or front shell. So these are all falls under cell position. These are all the classification or categories of my variable, independent variable shell position. We have used only one factor called shell position. We have analyzed three different position within this single variable. So how does sales has any influence on keeping the items in the different position or different places of a shell? So top shell and middle shell, front shell, we have seen it. Okay, and and then we concluded that since the f test value, f statistics value was greater than the critical value, we rejected the null hypothesis, and then we concluded that keeping the items in different place of the position has statistically different values of sales or amount spent by the customer. That is what we concluded it, right? So we rejected the null hypothesis because the statistic value is greater than critical value. You remember this diagram. So the f distribution is something like this, and it's something like a positive. Here the critical value, and the f statistic value was falling. Since it is greater than critical value, we got something like 3.89. Since this value was 20 plus, right, it was falling in the rejection rate. We rejected the null hypothesis. So in this case, we have used only one factor. There are situations wherein we will have to use more than one factor, right, to test it. So that's where the two-way Anova comes into picture. Two-way Anova is also called as two-factor Anova. So let us look at this example: south and region and rep. Here is the data set. So we need to do the test. Here does region and salesperson has any influence on the sales? Okay, so we have two factors. The factor one is region, other factor is salesperson. Does these two factors, here we have two factors. In this case, in the previous case, we have only one factor, self position, that's all. But here we have salesperson and region, right? So with these two, what if I have a two factor? What if I have a two factor to test the influence on these two factors on my dependent variable? See, the dependent variable is sales. Look at here. So this is the region. They said this company sell the products across 5 different regions: south, north, east, west, southeast, and they have salespersons, and each salesperson got deployed in different regions at different point in time. So we need to take a look at or we need to test and find out does these two factors, or whether region has an influence on the sales, whether salesperson has an influence on the sales, or say the region and salesperson both have any influence on the sales. That is what we are going to test it out here. So in this case, the data were given. So in the salesperson one in south region, right, he sold 2 items, and rep 2, 4, and so on. Here what we are doing is, let me see if I can download this one. If I download it, it is not possible to download. Okay. Here I cannot see the formulas. One second, let me just download is there. Yeah, good. But if you can use the statistical software to do the test, it's very simple. But if you understand the manual way of doing it, is good. See, if you go for an interview with Tiger Analytics and other analytics companies, they will expect everything manual. Okay, a formula, why we are using in the denominator so and so thing, and the numerator, why do we use this thing, component, they will ask all things. Okay, so we got this one, and let me just see it here. Okay, for the formula, everything is there, good. So now what we do is, here in this case, if you go to the data thing, and you have something called data analysis, it is not there, right? Okay, so you need to go to the file, and even Excel conducting the test I worked long back, and we will see how we can do that. So where is the properties? The properties not there here. Okay, since mine is not the original version in this laptop, it is not showing the property. Okay, well, let me see the account. No, anyhow, I'll give you the context. So in this case study, we are going to use two factors. If I have a two factor, how will I test whether sales is influenced by the region factor or salesperson factor, or the combination of two. We will check it out. And here in two-way ANOVA, we cannot see the combination of these two. Okay, we basically want to find out the effect. What is the effect of the region and salesperson? If you see the salesperson, we each salesperson deployed across various regions. And here what I did, I just took the average of this one, and here also we took the average. This is overall average. If you see before to all these things, okay, and this is the one. Let me do one thing. So when you click on here, you can see that all the data set, we took the average here, and this is for column wise average. Here we took it, and here see you have some data analysis thing. So if you go to properties, let me just check in my other laptop, office laptop, and see if I can connect it there, because there we have everything original version. You have something called options. Yeah, in the options, one second, let me just see if I have an option here. Yeah, since it is not since it's a trial version, I'm not able to see the option. But those of you have installed the Power BI and the Excel sheet, Microsoft Excel sheet, and if it is a original version, if you click on file, you will find something called option here. Okay, when you click on the options, it will open up a window. In that window, you need to click on add-ins. I will just go to the Google, and I'll show you here. Sorry, I should have checked it earlier, because because of hurry thing, I cannot do it. See here, Excel option. When you go to the Excel option, in the file menu, if you click on the Excel option, you will get something like this. Okay, you need to click on the add-ins. When you click on the add-ins, you will find something like analysis tool pack. You will find something like analysis tool pack. One second. When you click on the add-ins, on the right side you will find analysis tool pack and various add-ins for different applications. You can find it here, euro currency tools, all the things. You need to click on add-ins. On the right side you will find analysis tool pack. When you click on analysis tool pack, it will get installed. Where in your Excel, under the data menu, in the data thing, right, you will find data analysis something here. When you click on data analysis, you will have a lot of options. One second, let me just install it in my other thing. Data analysis. Okay, I will just so you will find data analysis tool here. in the data thing. You need to install the add-in. So once you install it in the data analysis, data menu, you will find data analysis. In the data analysis, you will find, when you click on the data analysis, yeah, very good, Gilbert. That's good. Yeah, you can share your screen. That is a great idea. I will make you host, Gilbert. Yeah, that's good. If you can share your screen, that is very much helpful. Okay. Why don't you share it, Gilbert? I just made you a host. Open an Excel, no? You will not find this, the data analysis. You need to explicitly install it. I just repeat it one more time in the interest of non-IT people. I just go to the file menu, and you have an options in the file menu, and you will find add-ins. You need to click on add-ins, select the add-ins tool pack, and click on OK. That's all. And if you go to the data menu, on the right corner you will find the data analysis. Can you see data analysis? Look here, this is what your data analysis. Sorry, this is your data. This is the one, you will find it here. And here, if you click it here, let me just do it here itself because I just shared it here. Look here, you can find single factor analysis, two factor analysis, two-way Anova without replication, correlation coefficient, all these statistical related tests. You can do it here itself. And also not only the statistical test, even you can create histogram with this feature. Okay, and importantly, the hypothesis testing and Anova testing, you can do it with the help of the data analysis menu. You understood, right? So in this case, that's it. You understood, right? So let me just, I don't need this any longer. I just closed the AnyDesk. Fine. So now here I have shown you in my other laptop data analysis menu, right? When you click on it, you will get everything. So here what happens is, in this case, when you select all these values, and if you select two-way Anova without replication, it will generate a table something like this. It will generate a table something like this. Here the row 1, row 2, row 3, row 4, 5. And these are all related to my regions, and column 1, column 2, column 3, 4 are related to my these are all my rows, regions, and these are related to my columns, reps. Here it gives you the summary, right? So the count of how many number of columns are there in row 1, 4, and row 2, right? So we have 4 columns are there in sum. If you add sum all these values in row 1, you get 32. So 12, how I got 32 here? So 6, sum is 32, row 1, okay, it gives me, even this one will not give 32, right? So the average count is sum of 84, and this one sum is 18. Okay, here sum is 18, some value got changed, and here you have 66. Okay, and if I select this one, 50 only I am getting it, and count for row 1, row 2, row 3, row 4. Okay, here this one, this is column, right? 77. Yeah, column is coming out correctly. Column sum is 77, and for this one 84, and for this one it gives me 112, and for this one it gives me 116. Okay, and here okay, I forgot this one, the last one, right? So 32, so I did not include this one. So 32, it is correct. So sum is 32 here. That is what we can see. I ignored this one. That's the problem. I did not select this one. So you need to select all these things. So it gives me row wise total number of columns, and total values, total number of regions, sales in each region, and rep wise what is the sales made, okay, total sales. So and also we get the average for this one, and the variance also it gives us the variance. Okay, we don't have to compute it. So we get all this information in Excel. So Excel is far better than using the statistical package. It gives me all this information. Next, I need to find out the effect here. So what is K9 minus 16? So here my K9 is average, right? So this each row average minus this one, I need to find out. This one will give me the effect. This is called your effect. And K10, so if I click on here, and this average minus this average, overall average, it gives me the effect. Okay, so I'll tell you, why we need to find out the effect, okay, a little later. And similarly for each column we need to find out the effect. How did I compute the effect? So you need to subtract each column average from this one. 16.8 minus 19.5 4.5, you get minus 2.65, this one. And since this value is bigger than this one, we are getting positive values. 23.2 minus 19.45, we get 3.75. So got it. So, and also if you scroll down here, it gives me an Anova table, the sum of squared, degrees freedom, mean squared, and f statistic value, p value. Look here, the critical value also given here automatically, right? If critical value is also given, we don't have to manually go and the lookup in the table. The degrees of freedom also it is given. Even for the columns also we have the degrees of freedom, and everything is available. So we are getting 4.39 here. And here the errors also it is giving us here 186.3. We don't have to worry all these things, okay. And here only thing is we need to look at the p-value, okay. And or you can use critical value. So there are two approaches I told you. One is the critical value method, other one is p-value method. In Excel you can get both the values. Even in the most of the statistical software packages, when you use any method or functions, right there it gives you both. So usually we go by the p-value. If you look at the p-value, 6.09811 e minus 0.5 and 0.018. So what is my alpha? All of you please type it in the chat window. What is alpha value? I told you alpha, right? What is alpha value? Very good. Someone typed. Very good, Karthik. How about others? Karthik and Mala, very good. And how about others? Correctly typed, Karthik and Mala. How about others? This is very basic thing, fundamental thing. I told you several times. Don't forget alpha value. What is alpha? All of you please type it in the chat window. What is alpha value? See, even if you don't join online, it is fine. But it is important to watch my video. That is very, very important. Okay, how about alpha value? I told you P is less than alpha. You are supposed to remember it. What does it do? So if the P value is less than alpha, what are we going to do? Mukilan, are you there? Mukilan, yesterday you typed it. I think Mukilan is not there in the call. Yeah, Mukilan also alpha value. If P value is less than alpha, what are we going to do? P value is less than alpha, what are we going to do? Yesterday you typed it correctly, Mukilan. Mukilan or Mala. Mala you typed it. So what is P value is less than alpha? Reject the null hypothesis. Please remember, Aruna, can you understand what I am telling you? P is less than alpha. If you get the P value less than alpha, you need to reject the null hypothesis. So okay, reject null hypothesis. Very good, right? So reject null hypothesis. Yeah. So that is the thing. So here, what is reject? Don't put reject null hypothesis. Okay. Here, can someone tell me what is the null hypothesis and alternative hypothesis? What is the null hypothesis? What is the alternative hypothesis? Region has influence on the sales. Region has no influence on the sales. So how many null hypothesis alpha? No. What do you mean by false, Jivananda? False. What do you mean by false reject? It's not false reject. Okay, and look here. So here we need to test. We need to conduct one more test because we have two factors, right? salesperson has influence on the sales. The other factor or other is salesperson has influence on the sales. The alternative hypothesis, salesperson has no influence on the sales. So we need to conduct two tests, okay, and this is the hypothesis. We define null hypothesis. We simply assume that region has influence. See, in the case of hypothesis test, we are very positive, right? So we always think things can go well. An alternative hypothesis, what we wanted to test, okay, we want to test region has no influence on the sales or salesperson has no influence. What you wanted to reject it, right? And so this is the one. So region has influence on the sales and region has, we need to conduct these two tests, but this is pretty handy. Yes, we can say, okay, that is Anova test. Anova, one way Anova. Okay, here also what he says is, he says, the region, right? So regions, see here, it is slightly different. Okay, region has influence on the sales and salesperson. Let us not complicate with that one. Let us understand this. So here we are going to test it out. We can say this way also, right? The south region sales is same as north region. Is that what you're saying, right? So we don't have to get into that one. First let us understand the big picture. Region has influence on the sales, salesperson has influence on the sales. Okay, and this table is pretty much helpful. If you look at the rows, what is rows? What does it rows tells us? What are these rows? All of you type it in the chat window. Aruna, including Aruna, what are these rows? So here, see, it gave me the consolidated things of my rows and columns. And Aruna, are you there? Aruna, are you there? See, the rows are nothing but a region. I think, Aruna, you're not able to understand, right? So you're not typing it here. How about you're not able to understand? Okay. See, Aruna, it is very simple. Select all these columns, go to data analysis tab, click on the one-way Anova. It generates the table like this. This table is what is there to understand, right? It gives me up to this everything. I told you very clearly, so please concentrate here. This row 1, row 2, row 3, row 5 are related to regions. So south region, in south region, how many number of columns are there? 4 columns are there. So what is the total sales, a total value here? You need to add all, it add all the values. See, it is very simple one. Click on the data analysis, select all the values. It gives you the table like this, right? What is there not to understand? Right? These rows are related to regions, the columns are related to, that's all. Okay. Aruna, are you able to understand now? Very simple to understand. You don't have to think too much here. Very simple. Say yes or no. If you don't understand, let it be there. Still you are not clear? Okay, if you are not clear, you watch my video and then you get back to me. Okay, so that is the one thing. And here the column 1, this column 1 is rep 1, rep 2, rep 3, rep 4, rep 5. See here, the whole idea here is, Aruna, so we wanted to find out whether the sale is influenced by the region. The simple example is, for example, in Andhra, the Gomkura, right, that is very popular, right? So we use Gomkura as a side dish for the food, right? It's kind of a pickle. I think it's a pickle, right? Correct me if I'm not wrong, if I'm wrong, okay? So the Gomkura is a pickle, kind of a pickle that is very popular in Andhra Pradesh. So you don't need to do any advertisement. You don't have to give advertisement about Gomkura. You don't have to explain to the Andhra people what is Gomkura, right? So it is one of their favorite item. Okay. So in that case, the region is Andhra. You just think the city is or the state is Andhra Pradesh. Andhra Pradesh, obviously, the sales is influenced by. See, the sales is influenced because of the region. The Gomkura sales is more because of the Andhra Pradesh. Okay, in that state it is very popular. So whether you put a salesperson or not, the sales will happen as usual. Okay, the sales is very high for Gonkura pickle. Are you able to understand? But in that case, what we are trying to do is whether Andhra Pradesh, because of the Andhra Pradesh state, are we selling more the pickle, or is it because of the salesperson are we able to sell more pickles in that region? Okay, whether Andhra Pradesh has any influence on the pickle, or salesperson has any influence on the sales. Are you able to understand or not? I don't know. That is what we are trying to test it now. Say yes or no. I think you are not giving any answer. Okay, see, don't, I don't want to force you. You just watch my video one more time. If you cannot understand, you come back to me. Okay, see, right? So, yeah, with this example, I have given you the Gonkura pickle is very popular in Andhra Pradesh. Similarly, so we have something called papad. Papad, right? Appalam. Ambika Appalam is very popular in Chennai. Okay, that brand is very popular because of Tamil Nadu. Most of them they prefer this. Each state has its own favorite. See, if you go and sell in the north, if you go and sell more rice, you think you can sell it more in the north. Even if you try to sell more rice, no one like it. They prefer only rotis. Okay, in the north region, obviously more we can sell more wheat than rice. And see, each region has its own favorite items, right? If you go to the Bengal, right? So Bengalis, they eat more fish than goat and other thing, right? So they prefer. So there is nothing confusion. What is your confusion? Can you please tell me what is your confusion? Where you got stuck? Here you don't have to get confused anything. Whether region has any influence on the sales or salesperson has any influence on the sales. That is what we are going to test it out. That's why I did not use mu1 not equal to mu2 and all. I don't want to confuse that one. So your only thing is we wanted to find out what in which one of these two factors, whether region or salesperson, of these two factors, which factor led to increase in sales. Okay, so that is what we are going to test it. So you watch my video one more time. Okay, if I repeat it more time also, it will get when you watch my video you will get annoyed. Okay, so now you understood. So we have something called Gonkura pickle, and we have something called rice and wheat. In north region, obviously we can say, let's say you launched a new product. You just think that way. Okay, you launched a new product, so you just recorded the sales of that product in a table like this, and now you wanted to understand, so why I sold this many number of items. So if you look at this, even you will get confused whether the sale is I made this much, I sold this many units. Is it because of the region or because of the salesperson? If the sales is due to the region, what are we going to do? What are we going to do? Simple common sense. Aruna, see, let's there are two factors. Not only Aruna, it's for everyone. If the sales, if there is an increase in sales, if that was due to region, if it was not due to a salesperson, what are you going to do? Change the product? What do you mean by change the product? See, I told you, I gave you this scenario. See, we have launched recently a new, the snack, okay, eatable items, okay. And now what we are doing is we sold in different regions. We sold, this specific product across all the, or let's, we say Coke. you just assume that Coke is good for health for the time being, okay, or some drink, yeah, soft drink, okay. I don't want to promote this one, soft drink. So you launched a soft drink, and you wanted to take a stock, in each region how much we sold. Now we want to understand, is it because of the region the soft drink is selling well, or is it because of the salesperson? And if you know, if you get to know, if the sale is more because of the region, what you will do? What is the next action that you do it? You will reduce the head count, right? Why should I need 4 salesperson? Let me have only 2 salesperson. You cut down the cost. So do you do that or not? If the salesperson is not the cause for increase in sales, obviously, right? Yes, I don't know. I think with this you should be able to understand. Reduce it, or if it is due to the salesperson, okay, you think, okay, the salesperson's contribution is more towards our sales, then you can increase the salesperson, or you can retain the existing. Don't send them out, keep them as it is, or try to increase the salesperson. That is what we wanted to understand. Okay, so now to understand whether salespersons are the cause for the boost in sales, or the regions are the cause behind boost in sales. That is what we need to find out. Please concentrate here, very simple one. So these are the things we need to find out. Okay, here in this one, how I got it up to this, it is given by Excel. I did not do it. I just clicked on data analysis. I selected all these things. It gave me this one. That's all. 2-factor without replication. Very good. Only thing, I computed this effect. I subtracted each and every line's average from the overall average. I computed the overall average here. This one will be confusing. Why I should subtract? You need to watch my video at least 2 or 3 times. Fine. Okay. So it's something like okay, so here in the Anova table we can see rows and columns. What is rows here? At least can someone, all of you, please type it in. What is rows and what is columns? It gave me the summarized information for the rows and columns. What is rows here? Aruna, what is rows here? Yes, Karthik is correct. How about others? Column is salesperson and rows is regions. Then if you are not answering here, then that means you are not concentrating. You are dreaming something else. Right? It's not sales. Aruna, this is not sales. See, rows is here. This is the what the rows, south. I think you are not concentrating here. Okay, I think you are getting calls from your office. Okay, and south, north, these are all rows. Okay, so this is values. Okay, sales. Forget about the sales now. So I'm talking about the factors. One factor is the south, the region, which are rows. Okay, and other factor is what? Columns. That is your salesperson. Rows are nothing but your region. Columns are your salesperson. It gives all these values, fine, and importantly the F statistic value also it gives, and F critical values are also gives. Now you tell me, with this critical value and F statistic value, can we accept the null hypothesis or not? Let me see how many of you are able to answer it. How many of you have more IQ and more you are concentrating more? See, more than IQ is concentration, that's all. Yes, Jiva, correct, you are correct. Regions is equal to row, salesperson equal to columns. Very good, right? Okay, and right, so now you tell me whether I can accept the null hypothesis or reject the null hypothesis. Region, so you said rows is equal to region, Jiva, very good, and columns is equivalent to salesperson. Now you tell me whether we can accept the null hypothesis or reject the null hypothesis. Let me see how many of you accept the null hypothesis. What do you mean by accept the null hypothesis? Mala says reject the null. Since I said accept the null hypothesis because you are giving reject, the alternative is reject, right? So okay, Jiva, very good, and Gilbert, reject null hypothesis. Why? Since more than 0.5. So here don't use 0.5, only when it relates to p-value you need to compare with alpha. Here I am not talking about what you are saying is, okay, what she says, Mala, since more than 0.05, no, less than 0.05. See guys, please remember, Okay, I'm literally fed up. Okay, P is less than alpha. Please memorize. Do you have to memorize this one? Reject the null hypothesis. So what is right? If the P value is greater than alpha, do not reject. Don't say accept, do not reject the null hypothesis. Always use this term. See, if you don't remember it, these two simple things, I will not be held responsible. You go and take a training from Great Lakes or anywhere, this is the rule. Okay, and I expect this answer from everyone, but unfortunately I'm getting answers only from few people. So why is it that? I think I should charge more, right? Like Great Lakes. Only then you'll be very serious. You are not concentrating here. See, this is not. So please, because this is unacceptable. That's why I'm repeating all these things. P is less than alpha, reject the null. This is what I've been telling for the last 2 weeks, right? You've been talking. P is less than alpha, reject the null hypothesis. Please, P is greater than alpha, don't reject the null hypothesis. Mala was saying that, okay, she is saying that since more than 0.05, you're not, why you are comparing F value with P value? No, you need to compare P value with your alpha. Here I did not say anything about phi value. I'm talking about F statistic value and F critical value, isn't it? If the F statistic value is greater than F critical value, yes, this one, you remember this diagram, you remember this one. This is what? This is where your F critical value is there, and F statistic is what we got here. The F statistic is 17.45 and critical value is 3.259. If the statistic F statistic is this less than critical value or more than critical value? Sorry, is this less than or greater than the critical value? Obviously 17.45 is greater than this 3.25. 17.45 is greater than this value. Okay, hence it is falling in the rejection region area. There are two methods to decide whether we can reject the null hypothesis or not. One is the critical method, critical value method. Not only you, Aruna, so even the Tiger Analytics guys, senior guys, even other analytics companies, so they got stuck up here. Don't worry, okay, P value. But you need to remember certain basic things. Critical value method. Here, test statistic value is greater than critical value. You need to reject the null. Look here, the test statistic. In this case, the test statistic is F statistic, right? F stat. In the case of T test, T statistic. So here the F statistic value is 17.45. Since it is greater than the critical, this is the cutoff, right? So this is, you just think this is India region, but this guy is the F statistics not falling in the India region. Hence we are rejecting him. Okay, 17.45. This is 17.45 is greater than critical value. Hence we are rejecting the null hypothesis. There are two approaches. The other one is P value. So P value also given here, plain vanilla. You don't have to do anything. So is this P value less than alpha? We know what is alpha. Alpha is 0.05. Simply keep it in your mind. If I ask alpha at any point, remember 0.05. Okay, until I finish this training program, until I tell you, you need to think 0.05. P is less than alpha. What is the P value here? Is this P value less than alpha? All of you please confirm it. Karthik, why do you say P value is greater than 0.05? No, right? Guys, then you don't know maths. See here, E minus 0.5. And how about Vidya? So P value. What is P value here? So whenever you find a value like this, okay, E minus, if the value ends with E minus 0.5, E minus 0.4, That means, see, this is nothing by 1 divided by 10, 1 divided by 10 to the power 5, 1 divided by 10 to the, so 6.09811 into 1 divided by 10 to the power minus 5. So what is that? So 1 divided by 10 to the power 5. So what is that? It will be like, 0.0. Look here. Can you see it here? 0, 0. Look here. I just selected this one. It means, or simple way of remembering this one is, whenever you find in the p-value, after the value, right, 6.098, something like this, right, if you see e minus 0.5, that means you need to prefix this value by 0.4 zeros. If it is minus 7, what you will do? If it is 0.5, put 4 zeros here, simple. 0.00040 zeros, 609, that's the rest of the value, put it here. Is that much simple. If it is e minus 0.7, how much you will get it? How many zeros you need to prefix it? You need to put it here. Only one guy. So yeah, if it is 7, 6 zeros. Aruna, 6 zeros. Very good. If it is 10 zeros, e minus 1 0, how much you will get it? Did they not teach you as part of your see, you're all data science student, right? Yeah, if it is 10, 9 zeros, very good. Aruna, right? So please concentrate here. Yeah, very good. So that I'll be happy. Okay, otherwise I will scream if you if you don't respond. Okay. See, so, 0.5, e minus anything followed by e, right? E minus 0.5. If it is plus 0.5, what you will do? E plus 0.5. See, in Excel and even if you use any statistical software, instead of putting this big number, in short it will put it like that: 6.09811e plus, minus 0.5. If it is plus, you need to multiply this by what? Change decimal to right. Exactly, right? You need to change the decimal to right. So 1 divided by 10 to the power 5 here. If it is a plus, what you will do? So into 10 to the power 5, right? So here, instead of 1 divided by 10 to the power 5, what you do is 6.09811 into 10 to the power 5 directly. Okay. So 10 to the power 5, how much? 100,000. 100,000 into 6.08. Right, that's what I know. As Karthik mentioned correctly, change decimal to right. Okay, and suffix the zeros, right? So you understood. Please remember. Now you tell me this. Look here. When I selected this, you can see the exact value here, right? So 0.00060, right? So this is equivalent to this one. So it prefixed with 4 zeros. It means this is 0.0000 is somewhat close to 0, right? Very small value. And here 0.0. Now you tell me, of these two p-value, which one is very, very small? I need answer from everyone. Of these two p-value, which one is very, very small? Very good, right? Mala answered correctly. Rows is smaller. Rows are smaller. And Mukilan, very good. And Gilbert, 6 point. Yeah, so very good, Gilbert. How about Jiva? Row, very good. Okay, Aruna 6.0, very good, right? So this is the response. How about Vidya? Vidya, are you able to follow me? I think Vidya, you know statistics, right? I don't have to tell. Yeah, very good, right? So yes, so since and if you, the second approach is p-value. If the p-value is less than alpha, what is the p-value? It is 0.0000 and that value. So since the p-value is less than alpha, we are going to reject the null hypothesis, and even either case, we are going to reject the null hypothesis. So we are going to conclude, we are going to say region has no influence on the sales. We are going to reject the null hypothesis. Region has no influence on the sales. Okay. And even in this case, the salesperson has no influence on the sales. Okay. And that is what we are concluding this one. 1 second, sorry. P-values less than alpha, right? So the alpha is 0.05. We are rejecting the null hypothesis. Here, 0.01. 0.1 is obviously less than 0.05. We are going to reject null hypothesis. In this case, neither a region nor salesperson has influence on the sales. Okay, maybe as per the test, that is what we are going to conclude it here. And the next one is, with Anova itself, you can do the estimation. Okay, you can do the estimation. Supposing your manager is asking you, if I deploy the salesperson rep 1, okay, what is the predicted sales for rep 2 in north region? If I deploy the rep 2 person in north, how much sale can I expect it? Okay, based on this data, how much I can expect the average sales. So here I have something like predicted sales equal to, this is the formula we use it, overall average is this one 19.45 plus the effect plus region effect. This is my region effect, already we have computed it, and this is my rep effect, already we have computed. So the formula to get the predicted sales is overall average plus rep effect plus region effect. Okay, and if I ask you a specific question, what is the predicted sales for rep 2 in north region? So what is the overall average? 19.45. But here, if the region effect was significant and the sales representative effect was not, okay, and the predicted sales for, okay, if the salesperson, the region effect was significant, okay, so in this case, sorry, here I made a mistake, okay, here it is not, region has no influence on the sales, sorry, here it is like this, okay, and region has influence, that's what I was wondering, region, extremely sorry, okay, region has influence on the sales. How can we see like this, right? Region has no influence on the sales, then there is no point in estimating. Salesperson has influence on the sales. So if you reject it, yes, region also has an influence on the sales, salesperson also has an influence on the sales, okay, but in this case we put it like this, right? So it's not always positive, okay. What we wanted to reject, that should be there in your H0. What we want to reject, region has no influence on the sales, that is what we want to reject. What we want to reject, that should be there in your null hypothesis. Please remember this, okay, sorry for the confusion, okay. And here we are going to reject the null hypothesis, we are going to, region has influence on the sales and salesperson also has an influence on the sales. Now the question is, both of them are having an influence on the sales, but when you look at the p-value for rows, the region, it has it is highly statistically significant. The p-value is highly statistically significant, right? So compared to salesperson, region's influence is more on the sales than salesperson. That is what we are concluding it. Are you clear? Yes, sir, right? So Karthik, yes, and Mukhilan, yes, and Gilbert is clear. Okay, sorry, here it should be like this. What we want, always remember in the null hypothesis what we want to reject. Okay, region has no influence on the sales. Could you repeat last statement? So which statement you are not able to understand? What was it? Okay, the last statement was, okay, the last statement was, forget about the f value and the critical value. Let us simply take the p value. Since this p value is much lesser than this one, right? So this one is equivalent to 0.000609, something like that. So this is somewhat close to 0, right? But here this value is a little bigger than this, right? If the p value is very less, then it is highly statistically significant, which means right, so we have a stronger evidence that we can say that we can reject this null hypothesis since the p value is very less. See, if the p value is very less, that means, right, this is the highly statistically significant. This is you forget about statistically significant term, okay, but you literally go by the crude term, right? So whichever of these two people, which one is very less, this one is very less, hence this right. So here in this case, the rows region has higher influence on the sales than salesperson, right? So but in statistical term, what they say, right, since the p value is very less, it is highly statistically significant, okay, and here it is statistically significant, but it is highly statistically significant, okay. So we are going to reject the null hypothesis, and even in both the cases we are going to reject the null hypothesis, and we are going to conclude this one. Okay. See, the lower the p-value, the greater the statistical significance of the observed difference. Okay. If the p-value of 0.05 or lesser than 0.05, it is generally considered as statistically significant. I explained you what is statistically significant. If the highly statistically significant means the p-value is very, very less. Okay. So what is the p-value? P-value is nothing, the probability. What is the probability of obtaining the observed result? Let's assume that in this case the null hypothesis is true. Region has no influence on the sales, right? So what is the probability that this statement is true? The probability is very, very, very less. So what I don't know. I will tell you this example. I'll take a digression for it. Let's say if you ask me a question, what is the probability that tomorrow it will rain? And if I say the probability is 0.02, so what does that say? All of you, please. Probability values lies between 0 to 1, right? Probability values lies between 0 to 1. If I say 0.2 or 0.3, what does it say? The probability of raining tomorrow is, if I say 0.2, very good, Karthik. It will not rain. The chances is it's not. There is a chance of rain. See, you just convert that as in percentage, Aruna, for your sake. I think you did not understand. See, let's say 0 to 100, right? If I say 20% chance it will rain, what does it say, Aruna? Yeah, Gilbert, you are correct. Everybody is correct. Jiva also correct. And what about Aruna? If I said tomorrow, there is a 20% chance it will rain tomorrow. What do you think? What do you understand? Yeah, the chances are, it is not no chance of rain. The chances are very less. Very less. If I say 0, there is no chance of rain. If I say, if you instead of saying percentage, we are using probability value, 0 to 1. So 0 to 1, 0, 0.1, 0.2, 0.3, 0.4, 0.2. If I say 0.5, it may rain or it may not rain. If I say 0.7, the chances are high that it can rain tomorrow. Right? The same thing, you need to use it as a p-value is something like a probability. So in this case, the p-value is nothing but it measures the probability, nothing but the probability. What is the probability of obtaining this result? Right? Let's assume that this is true. Okay. So the probability is very, very less here. Right? The probability to support the null hypothesis is very, very less. You just think that way. The probability to support this null hypothesis is very, very less. Right? So region has low influence. No. I think you correctly answered so far, Gilbert. See, the chances here that the chances are the probabilities are very, very less that a region has no influence on the sales. That means the chances are high that the region has high influence on the sales. Okay. So the probability to support the null hypothesis is very, very less. That means, the probability support tomorrow rain is the chance of raining is very less. What does it say? That means it is opposite, right? The chances of raining is very high, right? You are saying that tomorrow the probability of raining is 0.2. I conclude with the test, the probability of raining 2%, the chances of 0.2 probability of raining tomorrow is very, very less, right? So this is not the correct example, or you just think that way. See, if the p-value is very less value, it is highly statistically significant. Statistically significant is lower the p, very, very lesser value. If the p-value, that means the statistical significance. So the greater the statistical significance, right? So the lower the p-value, p-value represents the greater the statistical significance of the observed difference. Okay, you just think that way. So since the p-value is very less here, we can say highly statistically. It is, you just think that way here. Highly statistically, low statistically significant. It's not a low, statistically significant. Okay. So compared to this, since this one, we don't have any evidence to support this one, we are rejecting it, and we are going to conclude region has influence on the sales. So finally, what we are going to see with this one, region has more influence on the sales than salesperson. That is what we are going to conclude. And now if you apply this formula here, we can estimate this one. So overall average is 19.45 plus the, here I mentioned already, the sales rep, this is 0. You just think this is 0. So the 19.45 plus 0 plus the region effect. So here I mentioned about rep 2 in north region. So what is the north region here? Second row, right? Second row effect is 0.295. So 19.45 minus 2.95 north region, and rep 2 is which column? Second column, right? So second column is this one, minus 4.05 minus 2.5. if you subtract from this one, so how much you will get? This is what you will get, 12.45. The predicted sales. Similarly, you can plug in the different values. What is the predicted sales for rep 1 in south region? So with this you can find out which salesperson should I deploy in which region. Okay, this is the one for this one, and if the region was not significant, and here we put 0 here, and here we consider only rep effect and overall effect. If the region was not and the sales representative effect was significant, the predicted sales for rep 2 in north would be, okay, here in this case I mentioned about no one noticed this one, the sales representative effect was not there, 0, right? Overall average minus the region, north region, minus 2.5 okay, in this case okay, we have to consider both, okay, to rep effect and region effect, minus 2.95 and rep 2 is so you will get 12 okay, sorry, this is the overall effect, okay, so this is the overall effect. Yeah, what I said was correct only. See, here you understood overall effect. In this case, you need to take into account of both rep effect and region effect. And if you consider the salesperson effect was 0, okay, you don't have to consider salesperson effect, only the region effect, right? Overall average how much? 19.45. The north region effect was minus 2.95. Minus 2.95 minus 19.4 is 16.5. If you consider region rep effect is 0 without salesperson, so what is the expected sales if I deploy a person in north region? Okay, if you consider the rep effect is 0, 16.5 region effect. If I don't deploy a salesperson, what is the sales and region effect? And if the region was not significant and the sales representative was, it is the opposite. So you need to say, I don't consider effect and 0 effect for the region, and rep effect only I am going to consider. So the rep effect is minus 4.05 minus 19.4. You will get so the 15.4. And now we need to use the 95% confidence. We cannot say always we can achieve 16. If I deploy a salesperson in north region, and if I consider the rep 2's effect is nothing, and okay, is this the sales am I going to achieve just because of region, or is this the sales that I can achieve because of the salesperson influence? Okay, all the time can I achieve all this? That's where we use confidence interval, right? So then with 95%, if rep 2 is assigned to north region, monthly sales lie between this value lie between 4.56 and this one. So how did I get this one? Here I have computed the standard deviation. Now do you remember I discussed about the Chebyshev's theorem? The Chebyshev's theorem plus or minus 2 standard deviation represent what? Plus or minus 1 standard deviation represent which area? How many of you remember the Chebyshev's theorem? At least you tell me the number, 3 numbers. I compared with I used heart rate example. 68, no one remembers. See, that is what descriptive statistics, all this, once I start the data science topic, right, you need to remember everything from the beginning. Descriptive statistics, yeah, 68, okay, 68, 90, 98, very good, Gilbert. Only Gilbert remembers this. In the Chebyshev's theorem, 68% of people's heart rate ranges from plus or minus 1 standard deviation. 90% of the people's heart rate, 95% of the people, not 90, 95% of the people's heart rate ranges between plus or minus 2 standard deviation. 99% people's heart rate ranges between plus or minus 3 standard deviation. So here I mentioned about this one. I just type it here itself. 95% area covers plus or minus standard deviation, plus or minus 2 standard deviation. That's why I'm telling you, you need to keep go through on all the topics regularly from the beginning. You need to remember everything. Okay, everything is interconnected. So this is what the thing, right? The bell curve, and here 1 sigma, 2 sigma, and 3 sigma, and here -1, -2, -3. Right, so the plus or minus 1 covers 68% of the area. You remember, see, it's not completely disconnected. Okay, in Python, pandas is a different topic and NumPy is different topic. It's not like that. Okay, this entire region covers 95%, right? Approximately 95%. Plus or minus 3 standard deviation covers 99%. How many of you remember this? The plus or minus 2 standard deviation covers 95% of the area here. And if you see here, if you say 95%, what is the standard deviation? Which area it covers? What is the standard deviation here? Plus or minus 2 standard deviation, right? The 95% area covers plus or minus 2 standard deviation. Plus or minus, see, this is the one, plus or minus 2 standard deviation, right? This area covers 95% of the area, right? 95%, we can say this way also, 95% of the area covered by plus or minus 2 standard deviation, or we can say this way, the plus or minus standard deviation covers 95%. We can say that way also. So here plus or minus. So now what I am going to do is I just computed the standard deviation, square root of K25. So here it is given something like error here. If you take the square root of this error, we get the standard deviation. This is kind of a variance. Okay, if you take this square root on the variance, you will get 3.940. So here plus or minus 2 standard deviation, you need to do this. And so here minus 2 into this one, it will how much you will get, plus or minus 2 standard deviation. Okay, minus 2 into this one, you need to multiply it. And for example, if you click here, right, so here it gives you the formula here. So this one into this one, right, so 2 into this one, 2 minus 2 into this one, so 12.45 minus 2 into this standard deviation. And if you click this one, and this is the one, okay, sorry, if you click this one and if you click it here, I'll share this Excel sheet to you all. So here this overall predicted sales plus 2 into this one. So in the best case scenario, if you deploy the salesperson 2 in the north region, the monthly sales lies between, so not this one, so he can achieve 4.56 to 20. We cannot say concretely all the time a person can achieve. If I forget about all the things, if the rep effect is 0, if the region effect is 0, so this is the thing. But forget about these two things. If you go by, if I deploy a person, the salesperson 2 in the north region, and let's assume that, let's consider both the effect is true or holds good, so we get this value, right? So this, so if I ask you a question, if I deploy a salesperson 2 in north region, can he achieve 12.45 sales all the time? Not all the time we cannot say, right? So we are going to define a interval here, right? So with 95% it's confident, plus or minus 2 standard. We got the error, and you have the formula here. You click here, you need to select this one and click here. It gives you the formula, right? So this 12.45 minus 2 into the standard deviation, it gives you the lower bound. This gives the upper bound. With 95% confident, you can achieve the sales between this range only. So using Anova, we can make prediction also. We can do estimation. We can do the estimation with Anova. Similarly, you can find out predicted sales for Rep 3 in North region, Rep 4 in North region also. You can do it. Fine. So with this, we are able to understand region has more influence than the salesperson. If I ask you any specific question, okay. So here this simple example, the sales rep is effect was not. I did not consider the rep effect here 0. Only the region effect. If you see this one, right? But here itself we can find out. But again, we cannot go by only one case. Okay. So what we are concluding is both region as well as salesperson has influence on this, sales. But compared to salesperson, region has more influence on the sales. That's a simple common phenomenon. Like pickle, Gonkura pickle, right? In Andhra, any city or any place, if you take, it is very popular. Whether you put salesperson also has an influence, but region plays an important role. Okay, instead of the pickle, right? You just think, you launched a new product. This product is very popular in so and so region. Hence, region has more influence on the sales in that region. And some region, because of the salesperson, the sale is going on. But here both of them, we rejected it, and we concluded that both of them have influence on the sales, but region has more influence than salesperson because this p-value is highly statistically significant. Okay, which means it's very, very less. Okay. Next one is the two-way Anova with replication. Two-way Anova or two-factor with replication. Here also we are going to consider two factors. So this is you just think this is your advertisement, this is price. Tell me the common scenario. Which one will work? Sorry, your advertisement. Which one will influence the sales? Simple common sense. If I give more advertisement, will that influence my sales? Influence the sales in the sense increase the sales. If I give more advertisement, will it increase the sales or not? If I give more advertisement, will it increase the sales? And most of them, they say yes. Okay, Aruna also says yes. Mala also says yes. How about others? If I spend more money on the advertisement, or if I give more advertisement rather, okay, so will it increase my sales? Yes, advertisement also will influence the sales or can increase the sales. But if I increase the price, like if I increase the price more, and if I give more advertisement, at the same time I'm keep increasing the price, will that have any influence on my sales? Palani is silent. Okay, I give more advertisement, but I'm increasing the price also. Will that have any influence on my sales? Price is more, advertisement also more. Yes, Jiva says yes. No, right? That's not the common phenomenon, right? People still think about the price. Yes, Vidya, right? The price plays an important role, right? No matter how much ad you give, people doesn't care how much ad you give. End of the day, they will see in the ad, they will see whether you give any discount or something like that. How much discount, any sale offer is there in the ad. If they find offer, that is the eye-catching thing, right? If the price is cheaper, okay, advertisement is more and the price is cheaper and you give more discount or offer, then they, the chances of influencing the sales by advertisement is very high. But if you increase the price more and if you give the advertisement, do you think people will come and just because you have money and you advertise it, and if you increase the price, you think they will buy it? No, right? They will not buy it. Okay. See, Dell laptop, Dell company, they gave more advertisement. The same configuration of the laptop with the Lenovo, the price is, let's say you find you found the price is 10% lesser than Dell. Lenovo also branded and Dell also branded, and the same configuration of the laptop in Lenovo is 10% lesser than Dell. Just because Dell is giving more advertisement, will you still go and buy Dell's product? No, right? Okay. So we are going to analyze these two factors, whether advertisement has any influence on the price or price has any influence on the advertisement. And also we will check, this one, whether low advertisement and low price can lead to increase in sales, or whether low advertisement and medium price, low advertisement and higher price. And here I computed the effect. Okay, and here row wise total, if I click here, you can see that. So why we call this with replication? Here we didn't, we call this a Anova without two-way Anova without replication. Here we call two-way Anova with replication. See here, if you see the two factors, south region and rep 1, see we have only one record, right? For each row we have only one record for this column, right? So here for these columns we have more than one record. So we have noted the values in different point in time, 3 different point in time. We reduced the price, and then we gave low advertisement, and with low advertisement, low price, how much we made, how much sales we made, and with the low advertisement, higher medium price, how much we made, with low advertisement, high price, how much we made. Okay, and the 3 different point in time we have noted this sales performance. We noted this. So since we have replicated more than once, we call it a replication, two-way Anova with replication. So 2 factors, but we have multiple records. Okay. Now what I did here was I just select this. Here I took all these values, I computed the effect here itself, and then here I selected this effect I computed for all these values, average. The average this one, but here you look at here E minus overall average. First you need to find out the overall average, and each group, I call the group in the sense all these values. So overall average minus this group average, and overall average, see overall average minus this average. Okay. So this is the one gives me effect. The same way, if you go to the data analysis, if you select 2 factor with replication, the data analysis, you will get a table something like this. This is slightly different. Even though it is different, we will have to look at the Anova table only. We don't have to worry about all these things. We have already seen it. But here we have computed the effect here itself. Okay, and it here we are able to get the error here 5 point say this one, right? So within mean squared error. Okay, so this is what the error, we are able to get the standard deviation also here. And so now you tell me what is sample here, what is columns here. Here in this case the sample is nothing but the rows. Okay, advertisement. Sample is nothing but the advertisement. The columns are nothing but your price. The interaction is, does advertisement and price, both of them have any interaction? With the combination of these two, can we see any influence on? In this case, we need to conduct 3 hypothesis test. Okay, because here we don't have the interaction. Does the combination of region and salesperson has any influence? The combination of these two, that interaction we did not, we cannot test it in two-way Anova without replication. With the replication, It gives you the interaction also. Now simply you just look at this and tell me which one is highly statistically significant. Which one is highly statistically significant? Yeah. How about Aruna? Aruna and Palani. Palani you are not telling. Karthik. And how about others? Sumati or Jeevan. Rose. Very good, right? In this case, rows are nothing but sample. Rows. Okay. But here we have E minus 0.5. Na? What does this 0.5 says? Okay. You don't have to. Here 4 zeros you need to prefix it, right? Here 3 zeros. Here we have 4 zeros. Look here. If I select this and if you go to this formula bar here, 0, 0, 0, 0, 4 zeros are there, right? But here we have only 3 zeros. So the columns are price. With this simple common sense, it tells us, right, this p-value is highly statistically significant compared to other values. But interaction, what it tells, the combination of these two has an influence on the sales. No, 0.75 is not less than 0.05. It is greater, hence we are going to reject the null hypothesis. We cannot reject the null hypothesis. We say what is the null hypothesis in this case? The combination of advertisement and the price has an influence on the sales. Right. So that is what the combination of these two has no influence, right? You are failed to reject the null hypothesis. We are going to conclude that the combination of these two has no influence on the sales. Got it? See here basically we conduct 3 hypothesis tests. One is H sub 0, the advertisement has no influence on the sales. Same thing, it's sub 0. Here the price has no influence. So you know what is alternative hypothesis? The opposite. So the next one is both advertisement and price has no influence. So 3 tests we need to conduct in the case of two-way Anova with replication. It gives us the interaction also, right? So now you tell me what is the do not reject null. Which one do not? See, you need to tell me something like this. H sub 0, the first test, second test, third test. Tell me first test, can I reject or not? Second test. You see, your answer should be like this. First test and second test. You need to compare the p-value. No rush. Okay. Second test and third test. Only one response. How about others? First, Karthik, okay. First reject null hypothesis, superb. And second reject null hypothesis, very good. How about the third one? Third also reject null hypothesis. Why? Karthik. Oh, okay. Third, no, right? Okay. You are saying third, do not reject null hypothesis, right? So here, HAS. I don't know, why don't you give one more try? Yeah, first reject null hypothesis, second reject, super, right? Don't reject, fine. So Aruna also now picked up. How about Palani? Palani, are you able to understand or not? Palani, you are not responding. தமிழ்லையே டைப் பண்ணுங்க, ஒன்றும் ப்ராப்ளமே கிடையாது. So Aruna, okay, how about others? See, Aruna and Karthik, they mentioned it correctly. Palani, Vidya, correct. Thanks for your contribution. Reject, do not reject. Very good. Fine. So failed to reject the null hypothesis in this case, and we are going to conclude both of them have no effect or no influence on the sales, right? The combination of these two. And of these two, advertisement price, right? So here Okay, now what you do is you need to find out the same way the predicted sales. Okay, with the predicted sales for low advertisement with low price, what is the estimated sales? This is an assignment for you all. Give it a try. Okay, anyhow, we use the machine learning model to make a prediction, everything. Since it took more time now, right? So we will continue the machine learning, introduction to machine learning next session. With in the introduction session, we'll discuss about the deep learning related use cases, all the things. Okay, and then the next Sunday, we'll start the linear regression, and we'll gradually see everything. And also after completion of this one, we'll teach you the AWS machine learning. Okay, that will also the additional thing you will learn this thing. See, there are companies they use Azure, they use AWS, and if you know both, it will be good. Any of Azure also we have a separate plan, so that we will take it up later. At this moment, we'll focus on AWS. Okay, but first and foremost, you need to understand the algorithm. If you go to any interview, they will they expect you to be very good with the algorithms. Okay. And obviously nowadays the cloud is also another important factor. That's why the AWS I'll try to cover it. Okay, let me see. Okay, and whichever things. So even today I spoke to my student who attended the training with me 4 years back. Strong in algorithm, and important is the deep learning algorithms. Okay, deep learning and computer vision. You should be very good at it. And if coupled with the deep learning and machine learning, you can fly with colors. You can get an awesome package. Don't worry, we will proceed from the next weekend, the machine learning part, everything. Don't worry, we'll cover deep learning also. Don't worry. And now what I am going to do is I'll just show you which statistical packages that you can use it to perform this thing test. Okay, I just go here, the statistical test. Jeevan, you continue the same momentum, the chances are very bright. Okay, for you also to get into a much better job, salary. Sumati, for you also, right? The chances are very high because you're also statistics student. Okay, let me just open this one, the Jupyter notebook. I already started. I don't know why it got closed. But complete all the inferential statistics related assignments. From my past students and current students, those got placed, what I heard from them, right, they asked only some extent in the statistics part, and majority of the questions they were posed with the machine learning and deep learning. Okay, but when you go to analytics company like Tiger Analytics, Fractal Analytics, and Mu Sigma, they expect you to be good with statistics also. Anyhow, don't worry, we will take up the probability part later. This is my Jupyter notebook, new. I just go to Python. I'm going to open a new notebook, and we have a SciPy package, scientific Python. Freshers, don't worry, I have some other plans, but make sure that you are very good in everything. okay, sorry. Here's something like okay, I'll import this one. In the SciPy package, you have something called stats method. This is the one you can use it to write. This one has all the functions in it. Okay, mode function, all the things are. Mode is available here, and the NP itself, the mean, median, everything is available. And if you are using pandas, you don't have to worry all these things. So the describe, you remember the data frame name dot describe will give you all summary, standard deviation, everything. But anyhow, knowing this one, heart rates, for example, heart rate is something like 71, 78. What is this here? I just pressed something. My screen went blank. I pressed some key, it went off my. Okay, let me just restart it. I think it is there, right? The call is there? No, got closed. Yeah, sorry, my screen went off suddenly. Let me do one thing. So am I audible to you all? My screen went off suddenly, okay? And okay, I think you should be able to hear my voice now. Can someone type it in the chat window? Can you hear my voice? Can you see my screen? Because the previous sessions, the recorded video is getting created now. Okay, good. So thanks for the confirmation. Here I use something like heart rates, some value, okay, and here 78, 66 and 65 and 77 and 82, 68, something like that. That's all here. I just use np.mean. What is np? Np is numpy package. And what is my the list here? I have created a list by the name of heart rates. If I do this, you will get this is the mean heart rate. Okay, so this is something strange. One see here I mentioned 6577. That is the reason why it is giving something like that. 61. This is the average. Okay, you have np.mean. Similarly, np.median. Okay, you have np.median. If you want to find out the median of this one, so median is a function. You need to use the open parenthesis heart rates. This is my median. Okay, and if you want to find out the mode, there is nothing called mode function that is available as part of NumPy package. Instead, you can use the stats.mode. The stats thing, you have some mode here, heart rates, and here let me say not 8 will person will die, and here I will put 81 here again. Mode is 81. Look here. So this is the message. You know how to suppress this message, right? Import warnings. You have something called import warnings package, and using which you can disable this one. I already discussed about this, so you don't worry about this one. If I execute, it gives me the mode because 81 is repeating more than once. The mode is available as part of SciPy. I don't know how many of you remember that I have used a mode function while I explained to you about the data imputation, right? The same thing, the same thing I used it there also. Next, if you want to find out the variance, np.var, you have something called np.var heart rate. So what is the variance here? Okay, np.var give me the variance as 38, and standard deviation np.std. In the NumPy package itself, almost everything is available. np.std heart rates. This is the variance, all the things, and you have something called percentile, right? So if I want to see the 50th percentile, you have np.percentile, np.percentile heart rates, comma 50. What is the median value? 74, right? So this is the one. And if you want to see the value that is in the 100th percentile, you can need to specify 100, or say whatever value you want, you can specify. The 81 is this one. So percentile, standard deviation, variation, variance, median, mean, everything you can find out with the help of NP. And next one is the t-test. Okay, and how do we have something called t-test that is available as part of stats itself. There is a that is available here. And okay, what I will do is I'll start with the paired sample t-test. Okay, here import. Okay, we don't have to do it here, I did it already. I just create another file so that descriptive statistics we will have to a separate thing, and then we will have this thing a separate one. Here I'm going to say import scipy dot stats as stats some values. Okay, I just pre-value before exercise, after exercise, something like that. Okay, 34, 30, 28, 29, something pre, and I'm going to create another one for post. Or you can see the score, right? How much you scored in an exam. 30, 31 for 30, 30, and 31, 31. So here I'm going to say 32 for 34, and comma 38. I just say 32, 31, and 32, 29, 28, comma I put 30 here. Okay, and here stats dot t-test relative, okay, related, okay, pre and post. Look here. So can we see the critical value? This is the t-test statistic value, right? The test statistic value is 2.58, but we don't have the critical value here. It gives me the p-value. Very simple, isn't it? When you do it manually, so many steps. Here now you tell me, can we accept the null hypothesis or reject the null hypothesis? Are you all there? what is the, can we accept the null hypothesis or reject the null hypothesis? Only one person gave me the correct answer. Okay, and how about others? The p-value, what is alpha? You remember, right? What is alpha? I know you all exhausted, right? So continuously I've been talking. Yeah, p-value is Karthik has mentioned already. How about others? Others. If you can tell me the answer, we will wrap up now. Don't worry. So what is the alpha value here? What is the alpha value? It will not be there in this package, or it is there in your head. How about others? Who else is there? Mala, you mentioned correctly, right? Mala and Mukhilan has dropped off from the call. What is the alpha value? Gilbert, Jiva. What is the alpha value? Sumati. See, alpha is there in our brain, right? Alpha is, I mentioned 0.0. I think, I don't know why you people are not concentrating. P is less than alpha. We are going to reject the null hypothesis. What is the p value here? What is the p value here? Jivan, 0.0. Am I audible to you all or not? What is the alpha value? 0. I just put alpha here, okay? True. P is less than alpha. Hence, we are going to reject the null hypothesis. What is the null hypothesis here? See, we are pre-post, if I say, right, matched parity test, we are conducting it. In the case of matched parity test, we need to compare the pre and post, right? Before training and after training, what is the score? And the null hypothesis says there is no difference between pre and post. We are going to reject the null hypothesis, and we are going to conclude there is a scores as statistically different. The scores are statistically the scores are statistically different. It is not same. Before and after training, you just think that before and after training, can we see any improvement? The null hypothesis, no improvement. The alternative hypothesis, yes, there is a difference. Okay, and yes, we have something called post-hoc test. We will discuss this in the next thing. So now you understand. This is the package. We use it for t-test, rel, and we have something else called one t-test. Okay, that is for one sample t-test. Sorry, t-test independent. Okay, if you want to, let's say you just think these two are statistically, these two samples are different. Okay, completely different, mutually exclusive or independent. So in that case, stats dot independent, right? So stats dot t-test independent, and in this case, my A is equivalent to pre and B. Forget, see here, pre and post. You just think these two samples are coming from two different populations. Hence, these two samples are completely independent. Okay, and I say equal variance. Equal var is a reserved word. Okay, by default it is false. And if I do like this, what is the p value? 0.35. Is this less than alpha? Is this less than alpha? I think all of you are off. No, right? Karthik says no. Hence we failed to reject the null hypothesis. Hence we failed to reject the null hypothesis. And what is the null hypothesis here? Can someone tell me? Let me see how many of you, at least one person can tell the correct thing. What is the null hypothesis here? Here we have taken mu1 is equal to mu2, right? Mu1 is equal to mu2. Yeah, so mu1 is equal to mu2. And the alternative hypothesis says it is not same. The average of both the sample values are not same. It is different. Okay, that is what it says. This is independent test, two sample independent t-test, and this is matched parity test. Okay, and what else we have? If you put false, but if you don't specify equal var, something. That means that is your okay. It is getting late for me also. I have 8:30 office meeting. I will share these files. Don't worry. You can explore this one and you watch my video and start practice it. Okay. Any questions so far? Next weekend we will start the machine learning part. Okay. And in 3 or 4 weeks, most likely 3 weekends, 4 weekends will complete everything. August month we are going to complete it. Don't worry. Okay. The machine learning part will complete August month, and the deep learning September will complete it. NLP also